Hello everybody, today we're going to solve this system of linear equation using matrices. So we have three linear equations, and we need to write the augmented matrix for the equations. So remember, the augmented matrix consists of rows. Each row corresponds to one equation in the matrix, and each entry corresponds to the coefficient of the variable and the constant. So the first equation, I have 2x, the coefficient is 2, negative 5y, so negative 5 is the coefficient, 3z, 3 is the coefficient. The vertical line replaces the equal sign, the constant is 8. Now, the second equation, 3x, so we have coefficient 3, coefficient negative 1, and here coefficient is 4, and the constant is 7. Doing the same thing in the first equation, third equation, we have x, that means the coefficient is 1, the coefficient here is 3, and the coefficient here is 2, equal to negative 3. So this is the augmented matrix for the equations here. Now what we need to do is we need to transform this augmented matrix into a matrix in row-echelon form. Now to remind you, what is a row-echelon form? A row-echelon form for a 3 by 3 matrix would be, first it would have a 1 in the diagonal, and anything under the ones in the diagonal would be 0. And here you have A, B, C, D, E, F would be real numbers. This is a diagonal, all ones. So we need to transform this augmented matrix into a matrix that looks like this using row operations. Okay, so first thing we need to do is we need to make the first entry here in the first row and first column, it must be 1. Now we can, if we want, divide by 2 here, for divide the first row by 2. We can do that, or multiply by 1/2. But it would be better if we can interchange row 1 and row 3, because this one already has a 1. So let's do that. Interchange row 1 and row 3. So this means interchange the rows. So then we'll have 1, 3, 2, negative 3. Nothing's changing with row 2. And here you have 2, negative 5, 3, 8. So we took care of this one right here. Next, what we need to do is we need to make anything under that 1, 0. So how do I make this 0? If I multiply the first row by the opposite of 3, which is negative 3, so if I multiply the first row by negative 3, so this multiply the first row by negative 3, add it to the second row, R2, and put the result in R2. So that's what will happen here. Oh, sorry, this is negative 3. The opposite of whatever term you have here. Opposite of 3 is negative 3. So this is the same as writing like this. And this way we'll change row 2 and we'll make this 0, because negative 3 times 1 is negative 3, negative 3 plus 3 is 0, and this will be replaced with 0. First, let's write the first row. The first row is not changing. 1, 3, 2, negative 3. Now negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Negative 3 times 3 is negative 9. Negative 9 minus 1 is negative 10. Negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. Negative 3 times negative 3 is 9. 9 plus 7 is 16. So we took care of the first entry in the second row. Now you can, if you want to, write down row 3 as is, and take care of this element, this entry in the next operation. However, it would be a good idea for us to do the next step together with this. So we'll take care of these two zeros using this one in one matrix here. So let's do that. The opposite of 2 is negative 2. If I multiply negative 2 by row 1 and add it to 2, we get negative 2 times 1, negative 2. Negative 2 plus 2 is 0. And I'll take care of this 0. So remember, you change entries in the you change the entries into 0 using the ones in the diagonal always. So we use this one to make these two 0. We use this one to make this one 0. Okay? So let's go ahead and do this. We can do this here. Multiply the first row by the opposite of 2. Opposite of 2 is negative 2. Multiply by row 1 times R1. Add it to row 3 and put the result in row 3. Okay? Or you can also do negative 2 and this way here. You can ignore this for now. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Put the result in row 3. This is row 3. Negative 2 times 3 is negative 6. Negative 6 minus 5 is negative 11. Put the result in row 3. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. Negative 2 times negative 3 is positive 6. 6 plus 8 would be 14. So now the first column is taken care of. Next, we need to take care of this one right here. So we need to make this 1. Now, unfortunately, we cannot interchange any rows here anymore. So we're going to have to multiply row 2 by negative 1 over 10. So we need to multiply row 2 by the reciprocal of negative 10. So the reciprocal of negative 10 is negative 1 over 10 times row 2. So that will give us, row 1 is not going to change. Row 2, negative 110 times 0, 0. Negative 110 times negative 10, that will be 1. Negative 1 over 10 times negative 2, you can, if you want to, write it down here. Negative 110 times negative 2. So the negative become positive. 2 divided by 2, that's 1 over 5. So the answer here is 1 over 5. We're going to end up with fractions most likely, but these most likely will cancel out later on. You'll end up with integers for answers for x, y, and z. So let's do, we took care of these two. Now we have one more. Multiply negative 110 times R2. So negative 1/10 times R2. This is times 16. So that give me negative 16 divided by 2. They're both divisible by 2. 16 divided by 2 is 8. 10 divided by 2 is 5. So negative 8 over 5. Okay. So now we write row 3 as is. Okay. We're getting closer to what we want here. Now we need to make this one 0. Using the one in the diagonal. The opposite of negative 11 is 11. So 11 times row 2, this one is in row 2, add it to row 3 and put the result in row 3. So let's do this. We are not changing row 1, so I'm going to write it as is. And we are not changing row 2. Now let's go ahead and multiply row 2 by 11. So 11 times 0 is 0, 0 times 0 is 0. So these two will not change, okay? 11 times 1 is 11. 11 minus 11 is 0. Put the result in row 3. Now, 11 times 1/5, I can write it down here to make it easier. 11 times 1/5 plus row 3 plus -1. That will give me 11 times 1, that's 11 over 5 minus 1. So the LCD, again, I'm going to have a fraction. So here you have 1. I'll multiply this by 5, this by 5. We get 11 over 5 minus 5 over 5. 11 minus 5 is 6 over 5. 6 over 5 is your answer, and that would be here, 6 over 5. Okay, now one more thing here. Multiply row 2 by 11. So we're going to multiply row 2 by 11. So 11 times -8 over 5 plus 14. These are not going to cancel. So multiply 11 by -8. If you want to, you can do this. You're multiplying. 11 times -8 is -88 over 5 plus 14. Now we have fractions here. This is the same as 14 over 1. Okay, and now we multiply this one here by 5, this one here by 5. We get -88 over 5 plus, if you multiply 14 times 5, you get 70. 70 over 5, we have the same denominator now. -18 plus 70, that will give us -18 over 5. So this is -18 over 5. So we have one more thing to make it in row echelon form. We took care of the first 2 columns, as you can see. The 2 columns is good. Now we need to take care of this one. This needs to be 1. So there's no problem. We can multiply the third row by the reciprocal. If we multiply by the reciprocal of 6 over 5, this will turn into 1. So let's do that. The reciprocal of 6 over 5 is 5 over 6. So 5 over 6 times row 3. So we are no longer doing anything with row 1 and row 2. We write them as we have them here. 0, 1, 1 over 5, minus 8 over 5. Now 5 over 6 times 0 is 0. 5 over 6 times 0 is also 0. 5 over 6 times 6 over 5. Remember they're reciprocal, so this one would be 1. Okay, now 5 over 6 times -18 over 5. You can if you want to. Let's do this here. 5 over 6 times -18 over 5. So this 5 cancels with this 5. You're left with -18 over 6, which is none other than -3. Okay, so this one would be -3. So now we write the corresponding system of equations. Remember, the first column represents the x variable, the coefficient of x variable. The second column represents the coefficient of the y variable. And the last column here, the third column, represents the coefficient of the z variable. So let's do this. We have 1x, or x, plus 3y plus 2z equal to -3. That's our first equation. The second equation, 0x, so I can ignore that, plus 1y, or y, plus 1 over 5 z equal to -8 over 5. And the last row, that's 0x plus 0y, so I can ignore that, plus 1z. So 1z or z equal to -3. I already have a solution for one variable z. Now if I plug in the value of z in the second equation, that will help me solve for y. Okay, so let's do that. We have y plus 1 over 5. Z is -3. So you can plug in -3 instead of z here. Equal to -8 over 5. As you can see, the 5 is going to cancel out. I don't know if you can see it here, but maybe the next step. Y plus 1 times -3, that's -3 over 5, equal to -8 over 5. You add 3 over 5 on both sides of the equation. So this would cancel. So now you end up with y equal we have the same denominator, negative 8 plus 3, that's negative 5 over 5 equal to negative 1. As I told you, we'll end up most likely we'll end up with answers that are integers. So even though we had fractions, the answers are integers. So let's go ahead now, plug in y and z in the first equation to solve for x. And so let's do that. We have x plus 3y. Y is, we just found out what it is, which is negative 1. Plus 2z plus 2. We just found out z. And here is negative 3 equal to negative 3. So again, we're going to have x is going to be in integers, not going to be fraction. So x, 3 times negative 1 is negative 3. 2 times negative 3 is negative 6 equal to negative 3. So x minus 3 minus 6 is minus 9 equal to negative 3. You add 9 on both sides of the equation. This cancels, you and end up with x equal to 6. So we have x, y, and z, the solution. X, y, z, x is 6, y is negative 1, z is negative 3. That is your solution right here. If you plug in x, y, and z in the original 3 equation, you'll find out that they're solutions to the system of linear equation. I hope you found this video helpful. Have a good day, everybody. Bye-bye.